All right, this is officially the beginning of Unit 8, where we're looking at confidence intervals. We're not going to get too far with it today, so it's actually going to be a pretty chill Monday, and we'll get into it more. Maybe something worth talking about is what the timeline is. So the test for this is still, I'm planning on it being Friday, and I'm planning on just keeping our schedule just shifted back a few days based on how everything went around spring break. And the important thing is that we do have a little bit of leeway. If we stick to the schedule as is through the rest of the semester, then we will have about 13 days of review before the AP test. And I know some of you are taking it, some of you are not, but I want to have as much time as possible for review before we get to the AP test. So anyways, if we finish as is, we'll have 13 days. If we need to extend that time a little bit, then for certain units, we might add in an extra day or two. And then, of course, that cuts into the review time. But I just wanted to kind of give you a heads up of where we're at. Okay. So now let's jump into this. Unit 8, Day 1. So this is, now I did make this in the fall, and this was the most recent Arizona polls for the upcoming election. Of course, now the election has passed. We know how that went. But at the time, and this would have been around October, mid to late October. This is where the polls were at for just Arizona. So what are these polls trying to do? It's a conceptual question here. What are they attempting to do? Maybe a different question to ask is, what is the purpose of these polls? Yeah, you can just say, you don't need to. No, you don't need to worry about that. I can repeat your ideas.
To say who might win, or likely to win.
Yeah.
When the election comes around.
Yeah, they are. It's basically trying to give us an idea of who might win. And in a sense, maybe this is another thing you're thinking about, maybe not, but they're trying to predict, right? So when you have a poll, there's a prediction inherent in it. And so, you know, that is the purpose. That's what they're trying to do. They're trying to predict the true value. And the true value we found out November 3rd on election day. Well, a week later, or whenever it was. But anyways, we found the true value of where the polls were, or where the true vote was. But these polls are trying to predict it. Okay, so this is a point estimate of the true population parameter. In this case, it's the proportion of voters preferring Biden or Trump. There was a true proportion of voters who preferred Biden, and we found that out. There was a true proportion of voters who preferred Trump, and it was really close to 50-50 here. Okay, so maybe these polls are actually pretty good as far as that goes. Okay, now this is another thing, and I'm using polls here because this is something you guys are already familiar with. So there's this idea of a margin of error. Now the pollsters know that whenever they commission a poll, that it is not they're not saying this is actually the outcome that you're going to get. This is based on our poll, what we think the outcome is going to be, but there's always a margin of error right here. And that means, well, what does the margin of error mean? Oh, you're fine. And anyone can jump in. How wrong it could be. There you go. Yeah, I mean, that's a good way of saying it. When this particular poll comes out, the second one right here, they're not saying, oh, it's definitely going to be 50% to 47%. They're saying this is what our poll shows, but our margin of error means this 4.1. If we're just looking at Biden, anything between 54.1 and 55 or 45 would be within the margin of error. And so that wouldn't be crazy for that to be the outcome. Now, if it was outside of that margin of error, we might wonder what went wrong. Okay. Do you think the true population proportion is captured by all these intervals? Now, we have the benefit of hindsight. When I asked this question in the fall, we didn't have the election yet. We have had the election. I don't know if you remember the breakdown. I don't remember the exact proportions, but do you think that true proportion, let's just focus on the percent that voted for Biden, all right, just to make it simpler. Do you think that every one of these polls captured the true population proportion in its margin of error? So like for this first one, I said it could go down as low as 55 or 45.9 or 54.1. Was there true proportion somewhere in that range? Those of you who paid attention to the election? It was in that range. So in fact, we could look it up, but do you think every single poll included the true population parameter? No, it's unlikely that all of them captured it. So if we look down, let's see, here's at this one right here, 44 to 48 for Biden and Trump. And their margin of error is 2.9. It's actually the smallest margin of error. And we'll talk about how we can affect the size of the margin of error. But they predicted Biden would get 44 with a 2.9 margin of error. So for this particular poll, anything above 46.9% for Biden would have been outside the margin of error. All right. Any questions? Is this all making sense? Okay. Now, Biden did end up getting over 46.9% of the vote. But according to this particular poll, that was considered an unlikely outcome because of their margin of error. But that can happen. Yeah.
Explain where you're getting that.
Oh, yeah. That's a good question. So I'm only looking at this one, the proportion for Biden. The margin of error means I could be 2.9 above that or 2.9 below. That's a good question, though. So it would be as low as 41.1 or as high as 46.9. So any range, any value between those would be what this particular poll predicted. Now, the true proportion was somewhere closer to 50%. It wasn't quite that high, maybe 49% range. We can look it up, but it was above 46.9. Now, the important takeaway is that a lot of these polls were pretty close. Not every one of them actually captured the true population proportion, and that can happen. So is it possible that the true population proportion falls outside the margin of error? Again, we have hindsight. When I asked this in the fall, we didn't know. It was just like a possibility. Yes, it is possible. Here we can say not only is it possible, we can see right here that it did. Okay. So when you see a confidence, this is a confidence interval, and that's what we're building up toward. When you see this, that doesn't mean it's absolutely going to capture the true population value. Okay. So this is a little bit of a different perspective on it. So suppose we looked at a new poll. Again, this will all seem outdated, but the concept will still make sense. Suppose I told you a new poll suggested that the proportion of Arizonans who will vote for Biden will fall somewhere between 44.8 and 53.2%. What is the point estimate for this poll? How do you think we could find out the point estimate? What's it?
Average.
The average of those two. Very good. So the margin of error, in fact, I'm going to go back to the previous page. The margin of error, the point estimate is this, like for this one right here, it's this 50%. That's the point estimate. But the margin of error is going to be symmetrically above and below to give us the full confidence interval. So in this particular problem, we have the full confidence interval. The point estimate has to be right in the middle. So we can figure that out real quick. 44.8 plus 53.2 divided by 2. And when we add that up, that is, what's that, 98 divided by 2, so 49. The point estimate for this one is 49%. Okay. What's the margin of error?
or
4.2. All right, and we can kind of just, there's probably different ways you can do that math in your head. It's not the most complex stuff you've ever had to do in a math class, but we could also kind of use those same numbers, 53.2 minus 44.8. So this gives us the range for our outcomes, and then we can just divide that outcome by 2, and that tells us how far we're moving above or below the margin of error. So that's going to be 8.4 divided by 2, and there's your 4.2. So we have a point estimate of 49, a margin of error of 4.2, and that creates our confidence interval. Really not too bad. Okay, so there we've got the idea, the confidence interval. Do you guys already feel like you're somewhat familiar with confidence intervals? Not necessarily how to calculate them, but just the idea and the concept of a confidence interval? Somewhat. Just conceptually, it's not a big stretch. So here we go. We have these formulas. These are not on your formula sheet. They're not formulas you have to have memorized because it's, though if you want to write them down, I encourage you to. It's almost something that, at least I hope, is kind of an intuitive idea. When we just went through and calculated the point estimate and the margin of error, then, you know, you probably could just kind of reason your way through that on an AP test without needing to have a formula. But at the same time, it's good to have that just for backup. So there you go. Now we're actually going to talk about margins of error and calculate them in different ways starting tomorrow. But there will potentially be conceptual questions where they give you a confidence interval, ask you to find the point estimate or the margin of error or both or something like that. And so you can kind of logic your way through it. All right, I'm going to move forward unless anyone has any questions. Okay, so we will start calculating and coming up with confidence intervals, but first we need to know what confidence means. And when we talk about a confidence level, we give that in a percent. So 90% confidence level, 95, 99%. 95, let me go ahead and say 95 is the most common confidence interval that you're going to have. But it can shift, and you know, there are reasons why it might be bigger or smaller. In fact, we're going to talk about the benefits of a bigger confidence interval or a smaller one. Okay, so we'll talk about, we're going to see visually here in just a second, but let's just start with the idea that the larger your confidence level, 99% in this case, the larger your confidence interval is going to be. So we'll see that. What just happened? Weird. Okay, that's where I wanted to go, but I didn't see the link for it. It just went there for me. Okay. So right here, what we've got is we're going to see a confidence interval. We don't need to worry about this part so much, except to see that we have the true population parameter, this green line right in the middle. So if we create a confidence interval, what we've got is this dot in the middle, which represents the point estimate, and the lines coming off to the side represent the margin of error. As long as the true population parameter ends up in the in this range somewhere, then we can consider that a successful confidence interval. Or successful isn't the best word. It's one that captured the true population mean, and that's what the goal is, population parameters. So let me take another sample. Oh, and this one happened to capture it. Let me take another. That one did too. I'm just going to keep going, and notice that it will intersect the line frequently, but let's see if it always does. I'm going to go until we miss. That one barely hit it. That one did. Eventually we're going to miss. There's no doubt about it. There we go. Now you can see the red one popped up. So notice what's going on. All these little kind of brownish dots underneath, this represents the sample that we pulled from the population. And every once in a while, we happen to pull a sample from the population that's maybe biased, not biased, but it's just we happen to get more on the low side or happen to get more on the high side. So when we do our calculations, the point estimate and the margin of error, the true population parameter is not even in that confidence interval at all. But then we do another one and it happens to work. And then we do another one, we keep going. So let me just sample another 25. And look at this. In these next 25, we don't see the individual samples, but we can see this one missed and that one missed. And I can keep doing this. Notice these numbers right here in brown. I've just done a total of 50 confidence intervals created. And 94% of them have actually captured the true mean, the true population parameter. So I'm just going to keep going. And you can focus on this percent right here. I'm just going to keep hitting 25. The numbers here don't matter as much, but notice that percent hit if I keep going. It's exciting. All right, let me get up to 1,000. There we go. So here's 1,000 confidence intervals created, and 95% of them that we created hit or captured the true population parameter. And this is where it all comes back together. So the idea of a confidence level and a confidence level is that not that there's a 95% chance that the confidence interval captured the population parameter, but that if we created a lot of confidence intervals the same way, 95% of them would capture the population parameter. It might not seem like it's a difference in what I said, but there is. And actually, I'll come back to that because there's a slide on it. So we can look at this a little bit more. Let me raise the confidence level. So notice what happens. I'm not moving it yet, but notice it's going to be a little bit subtle, but pay attention to the width of this margin of error. As I go down to 80% confidence level, look at how wide that is. Okay, and then notice as I move this up, that the width of that gets wider and wider. And now I'm at a 99.5% confidence level. It doesn't look like a big difference between this one, like this size right here and that one right there. Maybe it looks like a big difference, maybe it doesn't. But notice, look at this right here. Look at this fourth one down. If I have a 98% confidence level, the true population parameter isn't captured by that interval. But if I bump it up to 99, still doesn't quite capture it. If I bump it up to 99.5, or I'm sorry, 99 does. 98 doesn't, it's red. 99 just barely does. And that's important, and maybe just intuitively, visually here, it can make sense that if we have a wider net that we're casting, we're more likely to capture the true population parameter. All right, any questions on this? All right, we might come back and forth to this real quick. But of course, if I make this confidence interval very narrow, then there's a lot of them that aren't going to capture the true population parameter. In fact, 80% of them will capture it and 20% of them will not. And look at that, that actually worked out perfectly. 800 out of 1,000. That's crazy. Let's see if this 95 is perfect. Almost 951 out of 1,000. So let me come back to this real quick. I'll be coming back to the diagram in a second. All right. So this is kind of to go back to that interpretation of a confidence interval. It's tempting to think that 95% confidence means that there's any confidence interval in particular is 95% likely to contain the true population proportion. But think of it this way. Your confidence interval either contains the true population proportion or it doesn't. And there's hopefully a useful analogy here. I don't have a coin. I was looking to see if there's a coin anywhere near. I don't have one. Imagine I had a coin. All right, if you can stretch your mind that far. All right, what's the probability that I flip it and I get a heads? 50%. I haven't flipped it yet. And then imagine I actually flip it and I cover it and I ask you, what's the probability it's heads or tails?
100%.
Well, it's already decided. It's either heads or it's tails. It's not like a possibility in the future. It's already been decided. So we can say, this is kind of the way we can think about a confidence interval. There's not a 50% chance it's heads. It's either 100% heads or 0% heads. But what I can say is that if I did this 1,000 times, in the long run, 50% of the time, this will be a heads when I reveal it. All right, but it's not a 50% chance once I flipped it. Does that distinction make any sense for you? All right. All right.
Why does it change if you cover it?
It's when we're talking about, and that's a good question. When you're talking about the probability of a future event, you can talk about probability and chance, right? But if it's something that's already been decided, it's no longer probability because our confidence interval has been created. Now, if we move back to confidence interval, the confidence interval is created. We say it's either going to be at this low value or this high value or somewhere in between. It could be part of that or it could not. We don't know, but it's already been decided. There's no longer a probability that it's part of it because it either is or it isn't. But we can, and that's why we can't say, I will tell you, you will be, this isn't the best answer, but it is something that you would be counted wrong with the AP test if you, and in the class test, if you interpret it the wrong way. So the interpretation is basically, we already have the confidence interval created. It either contains it or it doesn't. But if we created many confidence intervals, 95% of them will capture the true population parameter. So maybe it's a little nuance that doesn't quite stick for you, but that is the distinction there. Okay, and that was just repeating what I just said right there. If we created many, we would expect 95% of them to capture the true population proportion. So a 99% confidence interval means that we would expect 99% of confidence intervals for sample size n to contain the true mean. Okay, so higher confidence, and this is where we can get into why would you not go with a 99% confidence interval every time? 99% confidence sounds a lot better than 90%. But there's a trade-off between precision and accuracy. And when we looked at that, I changed the confidence level up to 99%, and it was a wider range. Down to 80%, it was pretty narrow. So the trade-off is that we can be 100% confident that Donald Trump's vote proportion on November 3rd is going to be between 0 and 100%. I am 100% confident that's going to be true. In the next election, I'm 100% confident that one of the candidates is going to get between 0 and 100%. But it is accurate to the point of uselessness. I'm not wrong, but it doesn't help us in any way, right? Because it's very imprecise. Now, I could create a 20% confidence interval that estimates his vote share somewhere between 48.8% and 49.2%. That's a pretty narrow range, but it's so inaccurate. A 20% confidence level is not one that we would ever want to use. That's less than a toss-up, 50-50, right? So only 20% of the confidence intervals are actually going to capture the true population proportion. So it'd be so inaccurate to be useless. So we could have a really narrow range that is inaccurate, or we could have a really wide range that's imprecise and useless. So we try and strike the balance. And typically that's at the 90, 95, or 99% level.
And then just to clarify, when like a population or something, when there's more of
Okay.
but no overall confidence.
Does it relate to sample size?
Yeah, yeah.
Okay, because we're going to get into sample size in just a second, but I'm glad you're thinking of it. So what can change a confidence interval? The confidence level we talked about, the bigger your confidence level, the wider it is. And the sample size. And I'll just go ahead and show you right now. As your sample size goes up, the confidence interval decreases. So let me go back now to this. And let me now change, as soon as I change sample size, it's going to delete everything. Okay, this is a sample size of 20. All right. And let me just generate 25 real quick. I'm not going to change the confidence level, but now what I'm going to do is I'm going to decrease my sample size to 5. And I'm going to sample 25 again, and you can see the difference there. Now, the reason behind that is that if you only have a sample size of 5, and we saw this with our sampling distribution. In fact, let me just change this real quick. Notice, I'm not going to draw any samples and confidence intervals yet, but notice the sampling distribution. As your sample size increases, the sampling distribution gets narrower and narrower, okay? And we're already aware of that. If I jump all the way up to 200, look at that. There's 250. So the sampling distribution standard deviation is inversely related to the sample size, meaning as the sample size goes up, the standard deviation goes down. That also applies to our confidence intervals. So let me not jump all the way up to 250 yet. We started at 20. Let me sample 25. Let me double that to 40. And notice that they get narrower. Let me double that. Well, not double. Let me just raise it up to 100. And we can see that our confidence interval gets smaller and smaller. And if I jump it all the way up to the very end, you can see that confidence interval is very small. And yet, still, if I do this over and over and over again, let me just get up to 500. 95% of these are going to capture the true population parameter. Now, the reasoning behind this, the idea behind it, is that when I get 250, that's so many in the sample size that most of them are going to end up right in the middle. You might have an outlier, you know, here and there, but you're going to get so many right here in the middle that the average of the sample brings you right back into the middle. If you only have 5, I could easily get 5 samples over here that gives me a mean all the way over there. So a sample size of 5, not very reliable. So the bigger the sample size, the narrower the confidence interval, the better it is. Is this all making sense? Does anyone have any questions?
Yeah, that makes sense.
Okay. So there we go. And we're going to see in calculations how this works. So today it's just a conceptual overview of confidence intervals. All right. And there you go. Sample size goes up, confidence interval decreases in size. Confidence level goes up, confidence interval increases in size. So confidence level and interval are directly proportional. All right. So a 95% confidence interval for the proportion of people who will vote for Trump is calculated from a random sample of 500 Arizonans. How is the confidence interval affected if you change it to a 99% confidence level? Any thoughts there? So it started at a 95% confidence interval, or confidence level, sorry. And I changed it to a 99% confidence level. And you can do that midway through your calculation. If you decide you want a 99% confidence level, you can just change it and we'll see that just means changing one value. And then you can decide that. So if you decide to change it, what is that going to do to your confidence interval? It will increase the confidence interval. It's going to make it wider. So, we saw it in confidence interval like this, it'd make it a little bit wider, Now, how is the confidence interval affected if you polled 1,000 Arizonans instead of 500? So that's where it would decrease. Even if the confidence interval, confidence level stays the same, it's going to get narrower and it's going to be smaller. The margin of error will be smaller. So these are actually on your, well, this top one at least is on the AP formula sheet. And this is what we're going to be looking at starting tomorrow. So this is kind of a general way of thinking about it. You have your point estimate plus or minus your margin of error. So your point estimate is going to be whatever statistic you get from your data. So you might get a sample mean that you're going to use for your point statistic. And then you're going to figure out what's the confidence interval. And you can find, we'll talk about what this means tomorrow. But I can tell you standard error is basically a different name for the standard deviation for a sample. So that just gives you kind of a heads up of what to expect. There'll be standard deviation, there'll be your point value, and then the critical value is what we'll kind of introduce tomorrow. And this is kind of, like I said, the general formula for a confidence interval, just to help you wrap your head around it. But since this is available to you on the formula sheet, try and get comfortable with that language for it. And let me see, are we doing anything else today? A marketing research department for a candy company creates a 90% confidence interval for the proportion of candy shoppers that will buy a new flavor of candy instead of a competitor's candy from a sample size of 435 people. They found that between 8.4% and 17.3% of customers will prefer the new flavor. How should you interpret this confidence interval? Okay, and that's a
What do you mean by like how you should interpret?
all right. So, and that's a good question. So the question, if you didn't hear, is just like, well, how are we supposed to interpret this? It seems pretty straightforward. Do we just like copy down what it already says? What we would say, what we shouldn't say, let me say how we should not interpret it. We should not interpret it as there's a 90% chance that between 8.4 and 17.3% of customers will prefer the new flavor. So we can't interpret it that way. But we can say something to the effect that if we created many 90% confidence intervals, we would expect 90% of them to capture the true population parameter. And that's
really good true population parameter with the like bounds it gives us, or like with the 8.4 and 17.3, would you just find add those together and divide by 2?
Yeah. If you want to find the that would not be a bad thing to include. So if you want to include what the point estimate is,
Okay. Oh yeah.
you can. Yeah, you got it. Yeah, if you want to include what the point estimate would be, that would be a good thing to add. But I will tell you this: this kind of question is one that typically would be a multiple choice type question, and they give you 5 options for what an interpretation would be. All right, so they don't typically just straight up ask you this and leave it as an open-ended question. And anyways, so here is another way of interpreting that. We are 90% confident that the interval from 8.4% to 17.3% captures the true proportion of candy shoppers that will buy the new flavor of candy instead of a competitor's candy. So this is a template that we're going to be talking about over and over again. And this phrase right here, we are 90% confident that the interval from blank to blank. And then we're not saying there's a 90% chance. We're 90% confident. And again, it's like this language thing that you might be like, this is stupid. Statistics is just parsing language, and it's not very fun. But it is a distinction that's worth existing. I'll just say that. All right. So, however you feel about that sort of distinction between confident and 90% chance, that's where we're leaving it today. And so there is a worksheet posted on the Canvas page. You guys can look through that if you want to knock that out today. I encourage you to. If you read chapter 19, then we're going to be going over the calculations tomorrow. Okay. And that's all I have for today. If you have any questions, feel free to stick around. If you are good to go, have a wonderful day, and I'll see you tomorrow.